अटेंड नहीं करेगा बोला, नहीं करेगा बोल के।
Right, we'll start our session now. So, good afternoon, everyone. Myself, Suchit Gavaria. I'm BIM and Digital Project Delivery Specialist in Building Project Department of Ashgal. And today I'm going to talk about digital twins and how they're going to transform building management and performance. So, this session is more oriented towards knowing more about digital twins and how we are using them in Ashgal. So this is the structure of the presentation. We will first start with understanding with what is a digital twin. Then we'll look at the components and life cycle of a digital twin. After that, we'll see industry adoption and maturity. Then we'll see value and innovative applications of digital twin. In the end, we'll see Ashgal's initiatives and future trends related to digital twin. So the rise of digital twins. We're in a time of enormous technological evolution where construction 4.0 technologies like cloud computing, augmented reality, BIM, Internet of Things, artificial intelligence, robotics, and drones. All these are enabling smarter design and data-driven processes. These technologies also enable smarter design, real-time data sharing, more precise construction, and efficient operations, which pave the way for innovations like digital twin. So let's have a look at the history of digital twin. So this concept is not new. It was started somewhere in 1960 when NASA used the term living model. It was associated with the Apollo mission. In 2002, Michael Greaves of Michigan, he proposed mirror spaces model. It was used in context of product lifecycle management. In 2010, NASA officially used the term digital twin in their technological roadmap, and they called it as integrated multiphysics, multi-scale, and probabilistic simulation of a space vehicle. So the history of digital twin is not new. It's only that recently, with the evolution of a lot of industry 4.0 technologies, this concept is taking a lot of traction. So now let's try to understand what is a digital twin. So in simple terms, a digital twin is a virtual replica of a physical asset. So a physical asset can be anything. It can be a building, it can be a tunnel, it can be a road, highway. And in the concept of digital twin, we create a virtual replica of that physical asset. And the thing which makes it a more dynamic entity is that the digital twin and the physical twins are connected to each other using real-time data. So that's the link which makes the entire system of digital twin as more synchronized. So if you look at the definition coming from the Digital Twin Hub, which is an organization from Center of Digital Build Britain, they explain digital twin as a computer model, which is a digital representation of a physical asset. And they also say that a digital asset where a physical twin may or may not exist. So there is also a possibility that a physical asset may not be constructed at that point of time, but we are still calling it as a digital twin. So later in the presentation, we will see what do we call that term exactly, what happens when there is no physical asset. And the last is there is a dynamic data connection between the physical twin and the digital twin. So if you look at this diagram, there is a continuous data flow which is happening from the physical world to the digital twin. The data from physical world is collected using IoT sensors, and it flows into the digital twin, where this data can be utilized to decide, describe, predict, and describe. And once we've analyzed that data, this data is then sent back to the physical world, where we can take actions based on the data. If you go slightly more in detail about the composition of the digital twin, so overall there are 8 components of a digital twin. 6 on the virtual side and 2 on the physical side. On the virtual side, we see a virtual model of the entity. So this can be a 3D model of the entity. Then there is static parametric data, historical data, streaming data, analytics, and entity control. So all these are the components which belong to the digital twin. The digital side of it, and on the physical side we have the hardware, basically the sensors and the actuators. Now let's try to look at all these components in slightly more detail. So the first one is virtual model of the entity. Now we can develop a virtual model of the entity by using a lot of technologies like BIM, CAD, laser scan, LiDAR, and photogrammetry. All these are ways of collecting as-built data, and once we have this data, we can always have a virtual model of that facility. And that's the starting point for for any kind of a digital twin. The next is static parametric data. This is the design data, the properties of the model, of the asset, which are stored inside, most likely in the BIM models, and this can be utilized to perform analysis and then make decisions based on the data available on the digital twin. After that, we have the historical data. So this is the data which is obtained from variety of software platforms that monitor, control, and manage buildings like BMS, EAMS, and CMMS. So this is the historical performance data of the building, which is collected from the building itself, and then it is stored inside the digital twin. The next is streaming data. So as I mentioned that we always have this live connection with the physical asset, and there is streaming data which is always incoming from the physical asset into the digital model, and this data is also being stored, and we utilize all this data in the next step where we do the analytics. So all this data collected in the first 4 components are then analyzed using AI-driven algorithms, and we can make better decisions based on the data which is analyzed. The last is the entity control. So this is the ability of the twin to interact with the software, logic controllers, actuators, and motors. And so basically this is the ability of the model to send commands to the physical world, where we've decided what we need to do about the facility. The digital twin will send commands to the physical world where it's going to take action. And this is possible with the live connection with the synchronization, which is always happening between both the worlds. On the physical side, as I mentioned, we have two set of hardwares. One is the sensors. We have a variety of sensors in the market as of now. So sensors like temperature, acoustic, humidity, flow, all this data is collected using IoT sensors, and then it is streamed back into the digital twin. We call it as a telemetric data. It is streamed back into the digital twin, and then where it is stored, and we can make decisions based on these data. Then we have the actuators, which receive the command from the digital twin, so it is related to the entity control. The digital twin sends the command to the actuators, where the actuators perform that physical task, just like opening walls or changing temperature in HVAC system. So overall, all these 8 components make a complete digital twin, and the most important of all of these is the synchronization. So there's always a constant synchronization which is taking place between the physical and the digital world. And the role of synchronization is to make sure that both the entities they represent each other as closely as possible. So the data collected from the physical world is being shared to digital twin using the cloud and IoT technologies. Then there is also a concept of frequency or speed. So the frequency or speed at which we are collecting the data depends. It can depend from few milliseconds to like hours, weeks, and even years, depending on what's the use of that data. Then in the end, we have fidelity. So this is the degree of precision. So a highly precise model will give very highly accurate outputs in terms of analyzing the data. Now let's look at the life cycle of the digital twin. So the life cycle of the digital twin starts from early planning stages, where we don't really have a physical asset. So we plan, design, and then build that asset. So the life cycle has already started at that time. The most important thing here is the digital handover of the asset. Once we design this on a platform like BIM, it is very important to digitally hand over this BIM model to the asset management stage. And once we hand over this model to the asset management stage, we can utilize it for space planning and utilization, predictive plan maintenance, on-demand maintenance, performing monitoring and tuning, and asset and portfolio analysis. So during the asset management phase, the digital twin is getting more and more intelligent, and it is analyzing all the information it is collecting over the years of that facility. And this data can then be used for upcoming projects such as portfolio management, portfolio planning, and then this completes the overall life cycle of the digital twin. Now there is a very important concept called as digital thread. So it's the ability of the digital twin to collect all the phases of the project using a digital twin. So this digital thread ensures that data collected from various stages like design, construction, operation, and maintenance, it is linked throughout and it is accessible. So this is a very important feature of digital twin, and this is one of the best uses of digital twin, that it can link all the data together. So earlier I mentioned that there is a possibility where we may not have a physical asset in place. So whenever we are starting with the design phase with the intention to create a digital twin, that particular type of digital twin can be called as a digital twin prototype. Right. So in this case, there is no physical asset present at the site. The project is still in design. It applies to the capital project phase. And once we have designed that project, it is constructed, then it is called as a digital twin instance or simply as a digital twin. Now we look at the industries which are adopting digital twin. So almost every industry is now embracing digital twin in various aspects. So coming from energy, there are companies like Shell, where they're working quite a lot on digital twins. Then in space and defense, we've already seen that NASA is working quite a lot using digital twin. Then in automotive industry, we have Tesla, Rolls-Royce, all these companies, big giants, are already using digital twin. In AEC specific, related to real estate and construction, we have very good examples like Hamad International Airport is already a digital twin. And apart from that, we have Singapore City, which is a complete replica. They have a complete digital twin of the whole country itself. So there are many examples available at present, which are already, good references for us to start from. Now we look at the maturity levels of digital twin. So the basic level is level 1, where we call it as a descriptive digital twin. So it is a live editable version of the design and construction data. Here the model is, or the digital twin is not connected to the physical model, to the physical asset basically. So it is only a descriptive twin. In the next stage, there is level 2, we call it as informative digital twin, where the model is then connected to the physical asset. All right. So this is the time where the exchange of information starts taking place over the IoT. And the next is level 3, we call it as a predictive digital twin. So the data which is being collected from the informative stage, it is being utilized for analytics and predictive maintenance and asset management. In level 4, comprehensive digital twin adds simulation for future what-if scenarios. So this is a very good, these are some very good use cases of digital twin, but this is at slightly advanced level, at level 4. In level 5, a digital twin is completely autonomous. That means it has the ability to learn and act on behalf of the users, automating the maintenance and decision-making process. So higher levels of digital twin require higher digital transformation in an organization, and also higher levels of digital twin will offer higher business value to the company. Now let's look at the value which digital twin gives as a concept. So the digital twin leverage massive amount of data. It is utilizing this data, and in business terms, they add a lot of value by increasing productivity and reducing cost. By eliminating waste, optimizing energy usage and reliance on natural resources, then promoting sustainability and reducing carbon footprint or output, and avoiding critical mishaps and preventing unplanned downtime. So these are some of the high-level values which we can expect digital twin to offer to us. Coming to the applications of the digital twin have multiple applications, and we're going to see in slightly more detail in the upcoming slides how the digital twin can actually optimize all these applications. So something like energy management and optimization can be very well done with the digital twin, predictive maintenance using artificial intelligence. Then we have monitoring construction using digital twin as well, facility management, occupant experience, space management, scenario planning, sustainability, green building, carbon footprint calculation, all this can be done using our digital twin. So these are also a very high-level applications of of digital twin, but we will go in more details and we'll pick up some of the examples of, or we can call them as use cases. So now we have innovative application of digital twin, where the first one is real-time energy trading. So imagine a commercial building with solar panels generates excess energy on the sunny days, and the digital twin identifies this excess energy and it sells it back to the grid. So this is possible with the help of a digital twin. And on the contrary, on cloudy days, the digital twin buys cheaper energy during off-peak hours, balancing energy use to cut cost and support sustainability. So overall, there is a trading of energy which is taking place with the help of digital twin. It works on dynamic pricing based on the prices of the energy offered by the grid, and this can really optimize the energy consumption and also cut down on the operation cost of the facility. The next one is smart building marketplaces. So it is in this concept, or in this use case, a digital twin is connected to a marketplace. and there are multiple digital twins connected to a central marketplace. They can offer underutilized spaces like meeting rooms, parking spots to nearby businesses. Whenever we are not utilizing any meeting rooms or parking spaces, a digital twin can actually identify that, and then it can actually rent it out in a marketplace in real time. So this tracking usage and availability, the building becomes part of a more dynamic sharing economy. So this is a very high level, or I would say a very interesting use case of digital twin. Then next is facility design and retrofitting. So we have a lot of renovations in museums all over the world. So a digital twin can be used for renovation and retrofitting. So in this use case, a museum uses a digital twin to simulate design changes for new wing, allowing architects to test layout for foot, pedestrian movement, security, and aesthetics without disrupting operation. So the architects can actually make use of the digital twin, analyze the twin, and then make new designs based on the predictions done by the digital twin. So that's a very interesting use of digital twin as well. Then again, this is a very practical use case of digital twin, incentive-based waste reduction for building tenants. So in a multi-tenant commercial building, imagine a mall complex. We have a lot of food outlets over there. A digital twin of that mall can actually identify how much waste each food outlet is generating, and then it can give incentives to the food outlets for reducing waste and improving recycling. And this, it can do it in real time. This lowers the waste management cost and promotes sustainability amongst the team. Then another innovative application of digital twin is emotional AI for building interaction. So imagine a modern hotel. So the digital twin uses emotional AI to interact with the guests. So the digital twin is actually reading the faces. It can do facial recognition, or it can read emotions of human by facial recognition, body language, hand gestures, and it can use that data to adjust the atmosphere, to adjust the environment of that particular building. So in a hotel building, this can be a very relevant and very applicable use case. So the digital twin can actually adjust the lighting, room temperature, and it can also personalize the entertainment based on the emotions of the users. And this is possible in real time, and we have all these technologies available under this roof, I can say, as of now. We can find it's not for the future, it's something we can do it immediately. Then another use is construction monitoring. So imagine we are constructing a residential complex. The digital twin spots the error in a window installation in real time, and then it sends notification to the construction management team that we need to rectify it immediately, without waiting for the project management team to actually identify it, and then there is a long process of rectifying it. So in a digital twin concept, the error is identified in real time, and the mistake is corrected early, so the project is not running into a delay. Then another very practical use of digital twin is construction waste management. So in a construction site, the digital twin tracks the types and quantity of the waste generated. So it can identify how much waste is generated. It can also identify what is the type of waste, and it can suggest ways to reduce, reuse, or recycle the material. And it also coordinates with the waste management system like Baladia and sends notification to collect or proper disposal of these materials. Now that was an overview about digital twin. Coming to the topic of Ashgal's journey in terms of digital twin. So we are exploring digital twin on several aspects. There are several departments in Ashgal who are now trying to incorporate digital twin in their processes. So to start with, we have a good repository of BIM models. So we've been working on BIM implementation since last 5 to 7 years. I'm a BIM specialist myself. So we've got a good collection of BIM models which act as a starting point for digital twin. So if we have all these LOD 500 models, asset information models, we can utilize them and then build on top of these models. These are some of the examples. These are real projects and we've already completed. Some are ongoing and some are completed. So we have accurate as-built models of these projects, and we are planning to utilize them for digital twin and optimizing our building operations and management. Now coming to the point of software. So when it comes to the software, which are the softwares which are providing digital twin services? So in terms of deployment model, first of all, digital twins are available in several models like software as a service, platform as a service, and infrastructure as a service. And very recently, some companies are also offering digital twin as a service kind of a model. So which it's quite customized, and it is developed to provide a managed service for that particular facility. The next is emerging trends. So we've already seen that digital twin is quite capable of handling a lot of data. So a pairing of digital twin and AI is a very powerful pairing. So we need to leverage this pairing, and at Ajgal we are also working on ways to identify how we can leverage this kind of pairing capabilities with AI. And the next is there are more upcoming innovative technologies like metaverse. So digital twin will form the foundation for all the upcoming technologies like metaverse, and all these technologies can be built on top of the digital twin ultimately. So we've reached the conclusion of the presentation. So digital twin it's a big market. It's a $260 billion market. It's supposed to reach there by 2032, and digital twins are claimed to cut maintenance costs by 25 to 30%, reduce energy use by up to 20%, and increase the property values by 7 to 20%. And overall, this technology is the key to driving efficiency and sustainability in the construction and real estate industry. So if you're interested to see a real digital twin, a live digital twin in action, please visit our Ajgal Pavilion, where we have a live digital twin model for you, and you can go ahead and explore that. Our colleagues from Ajgal will be able to provide you more information about it. So that's all from my side. I really appreciate your presence here. Thank you everyone for attending. Are there any questions? Yeah.
Very much, very inspiring and futuristic approach. So, I mean, it's nice that you're talking about AI and data, but I'm also wondering actually how, I mean, you will be able to train your model and then build your models based on the hardware. So where will the hardware will be sourced from or like contracted?
That's a very good question actually. So now we are leveraging technology in terms of infrastructure as a service, so we don't really need to have a hardware on premise. So we're making use of platforms available from Microsoft and Google, where we don't need a lot of processing power on premise. So that is also one of the enabler of digital twin. So we can do a lot of processing of all this data, and that's why that is the exact reason why digital twin is a reality. It's not something very futuristic. Yeah. Any more questions? Yeah.
How are you? Thank you for the presentation. Just I would like to ask regarding digital twin and assets, especially when we have a legacy system and we need to build a digital twin to maintain the system with minimum changes in the configuration of the real-time and SCADA system and the control systems in the assets, and to interface with the new technology. How we could do it?
So yeah, again, thank you for the question. That's a good question as well. So the best part of digital twin is that we don't need to replace any other building management system. So it's a concept which sits on top of the asset management software. So it is interconnected to all the asset management softwares, where it can connect with BMS, CMMS, and other maintenance softwares. And at the same time, it is also connected to the digital world. So it's just like a linking platform. So it is very easy to, it's quite, I would say, very practical to link all these platforms together, even the legacy systems.
Use the current infrastructure and interface with the service provider and give you the data. That's it? Okay, thank you.
Excuse me.
Any more questions?
So since the connection, the data link connection between the physical and the virtual world is eventually going to be hosted on the cloud or Internet of Things, can you comment on privacy issues and data leakage issues and hacking issues, etc., cybersecurity?
Thank you for the question. So that's a very important point actually. When we leverage the technology which is based on the cloud, we make sure that we first of all trust that technology. So there are a lot of technologies available in the market coming from, again, Microsoft, Google. They are like established platforms, and they have certain protocols. They've signed all the MOUs, and they've signed all the data sharing policies. So according to Ashghal as a client, we've already taken care of that when we sign a contract, or when we make sure that we are taking or when we are making use of that technology. So the service provider, when we choose, let's say Microsoft in one example, they already have processes in place which make sure that our data is protected, it's not leaked, and it's being taken care of. So that's a very sensitive topic when it comes to sharing the data. I really appreciate that.
Yeah, I think there's a lot of risk management that has to come into play. So can you comment on the intensity of risk management and trade-off analysis that is being utilized? Because something like this can be a huge backdoor, and since infrastructure is involved, if there is a breach, then it could be a multi-billion-dollar infrastructure that is at stake. So can you comment on the business resilience and the risk management aspect that comes into play here?
So for sure, the risk management needs to be kind of revamped. It needs to be looked from a completely new perspective when we come to not only digital twin, when we come to talk about any technology, any innovative technology which is digital. So you will see that most of the technologies being adopted by Ashghal are now digital. So you will see that our risk management is also kind of getting a bit revamped. Our strategies identifying the risk are also getting molded according to the risk, the digital risks, I would say. So we definitely need that particular aspect in place. So that's a very important thing. And moving forward, I think for sure we will be able to make sure that the digital twin or the digital world is quite secure, because that's the only way. If we don't have a digital world which is not secure, it's not going to work.
Now, commenting on the regulatory aspect of this, I would imagine if I'm a minister responsible for the infrastructure of the country, I would have a lot of questions about exposing, quote unquote, exposing my infrastructure to digital twin technology, given that there could be possible breaches. So from a regulatory front, what are the obstacles, if any, that you have faced from regulators in applying this in a country?
Yeah, so coming from regulatory point of view, Ministry of Communication and IT, they have policies and procedures in place. So that's why we see that a live example such as the Hamad International Airport, which is a very sensitive facility, it has been able to make use of digital twin because of the structuring of the policy which has been done by NCIT
so
already.
It's using digital twins across the board for everything?
Across. They have a live model of the entire.
It is managed by digital twins.
It's managed by digital twin. You can visit their website. There are multiple articles on them, so you will find a lot of information about it. So it's happening in Qatar, and we do already have some lot of important policies which have been in place since a couple of years. And because of that, we are able to talk about concept like digital twin. Otherwise, as a government entity, I wouldn't be very comfortable to project in front of the audience. You have a question?
Are you facing the challenge to collect the data from existing buildings, especially for those systems years back? Because most of the systems like EMS, BMS are operating in silo.